All right, so today we're going to do more logarithmic equations. There's going to be two cases, as you will see. And if you rewrite the equation in the form of log equals log, the logs will cancel. If you rewrite the equation in the form of log equals a number, you rewrite it as an exponential equation. All right, so it's either going to be log equals log or log equals number. All right, example 1. We have log base 2x minus 5 plus log base 2 of x plus 2 equals 3. We need to combine this into one log equation. Okay, we have the log base 2 matches the log base 2, and we do not have a coefficient in front of either one, so we can use the product property. Log of A plus log of B equals log of A times B. All right, so since these are both log base 2, I'll keep the log base 2. All right, and this portion, this argument right here is your A. I'll write it on the top here. This argument right here is your A, and this argument right here is your B. Okay, the argument is the thing you're taking the log of. So log A plus log B, it's just going to be A times B. So log base 2 of x minus 5 times x plus 2. All right, I'll put brackets around both binomials combined because you're taking the log of both of those combined, multiplied by each other, and that still equals 3. All right, and now, since we have log equals number, we said we convert it to an exponential equation. How do we do that? Well, right here we have log base 2. I am going to make this entire expression the exponent on the number 2. And on the other side of the equal sign, I'm going to make that whole thing the exponent on the number 2. On the left, this base matches the base of the log, so those cancel. And you are just left with the argument of x minus 5 times x plus 2. And 2 to the third power equals 8. All right, now I see we're going to have a quadratic, and quadratics have to be set equal to 0 in order to solve. So we're going to have to unpack this and subtract 8 from both sides. All right, let's do FOIL. X times x, that's x squared. Inner is negative 5x. And outer is positive 2x. All right, if you want to combine them in one step, that's fine. And last, negative 5 times positive 2. And that equals 8. All right, this needs to be set equal to 0. The opposite of positive 8 is negative 8. 8 minus 8 is gone. Bring down your x squared. Negative 5 and positive 2 is negative 3x. Negative 10 minus 8 is negative 18. And that equals 0. Now we're in business. All right, you either factor or use quadratic formula. Let's try the factoring first. There's no coefficient here, so we just write out the factors of negative 18. And we want two numbers that add to negative 3. All right, and that's going to be negative 6 times positive 3. If you add these two, it's negative 6 plus 3, that adds to negative 3. And negative 6 times 3 is negative 18. So that works. All right, so we're going to use that in the new binomials. All right, we're going to have two binomials, and we have an x squared, so it has to start with x times x, and we have minus 6 and plus 3. And that equals 0. Anything times 0 is 0. So you can set this equal to 0, x minus 6, and you're going to get x equals 6. If you do x plus 3 equals 0, you're going to get x equals negative 3, because negative 3 plus 3 equals 0. Now, for these two, you have to test it. All right, you're going to have to test by plugging it in. All right, so let's go back to the original. Let's see. I'll erase some of this. Well, I'll leave it for now. If we use x equals 6. If we use x equals 6, that's going to be 6 minus 5. That's a positive 1. Remember, the thing you're taking the log of has to be positive. We would get 6 minus 5 or 1. That's positive. 6 plus 2 is 8. That's positive. So the 6 is okay. How about negative 3? If we put negative 3 in here, negative 3 minus 5 is negative 8. You cannot take the log of a negative. Therefore, the negative 3 is gone. All right, that doesn't work. And we're left with x equals 6 only. Okay, so you test, you plug it in, and I'll write, right here, log I'll just write log argument, abbreviate, log argument must be positive. All right. So in other words, the thing you're taking the log of, that must be positive. So that's it right there. All right, so this will be example number 2. And in this case, we can see that we have a log equals log situation. So what we're going to do here is combine the ones on the left-hand side, because we have log base 5 on both sides, but we want this combined into one term without a coefficient in the front. So first things first, in order to write it as a single logarithm or condense it, you want to get rid of the exponent. So this is 2 times the log of x. This x plus 1 is the argument, so this 2 is going to become the exponent on that argument. And I'll just cross off this 2 right here. Okay, and now we have a situation where we have log base 5 without a coefficient, and they are subtracted, so we can use the quotient property, and that is log of A minus log of B equals the log of A over B. All right. So that's what we're doing here. And this part right here is going to be your A. And this part right here is going to be your B. All right, so we have log base 5 on both of them. All right, log base 5. And that is going to be, the argument is going to be a fraction. In the numerator, the The a, the one that's first, is in the numerator, so that's x plus 1 squared. And the one that's being subtracted, that argument is in the denominator, so that's x minus 3. And on the other side, we have the log base 5 of 25. Now, this is actually pretty interesting. We can make this into a number. The log base 5 of 25, remember 25 is actually 5 squared. This number here is actually 2. However, we don't want it to be a 2 because what we have now, we have matching logs with matching bases on both sides of the equal sign. Okay, so really, since it matches on both sides, we can cancel the log base 5. We can just set the arguments equal to each other. Okay, if you don't believe me, what you can do, you don't have to do this, but if you want to make this the exponent on the number 5 and do the same thing to the other side, I'm doing the same thing to both sides, 5 and log base 5 cancels, and you're left with the argument, 5 and log base 5 on both sides. So this right here just equals 25. All right, so we have x plus 1 squared divided by x minus 3, and that equals 25. Now, it's too bad we have this denominator. If we didn't have the denominator, we could just take the square root of both sides, but we can't do that. All right, we're going to have to get rid of the denominator and then unpack both sides and set it equal to 0 because we have a quadratic here. So the opposite of divided by x minus 3, the opposite of dividing by x minus 3 is going to be times x minus 3. You want to do that to both sides. All right, on the left-hand side, numerator divided by denominator, that's gone. And let's see. Really, I'm going to unpack the x plus 1 squared, okay? I'll write it out. All right, some of you might be able to do this without writing it out, but I'm going to write x plus 1 twice because it's squared. Distributing on the right, 25 times x and 25 times negative 3. Okay, let's see. FOIL or distribute. X times x is x squared. Inner, outer, 1x, and 1x is 2x. And the last is 1 times 1. $25x minus 75. Okay, we have a quadratic, so we need to set it equal to 0. The opposite of positive 25x is negative 25x. And the opposite of negative 75 is positive 75. Cancels here, cancels here. Negative 25 and positive 2. Positive 75 and positive 1. And that equals 0. We can factor or distribute. I am going to try to factor. Okay, let's start with a 76 and write out the factors of 76, positive 76. And we want to find 2 that add to negative 23. Okay, tough one. 76 is divisible by 2. So 76 divided by 2 is 38. That's no good. What if I double the 2? That's a 4. And take half of 38. That's a 19. Okay, 4 times 19 is 70.
I'm sorry.
4 times 19 is 76, and they add to positive 23. We want negative 23. How about negative 4, and negative 19. That'll add to negative 23. And if you multiply them, it's positive 76. Perfect. So that is going to be in the binomial. All right, we have an x squared. So we're going to start with x times x. And we're going to use negative 4 and negative 19. And that equals 0, just like last time. Okay, either one of these equals 0. So we can do x equals 4 right here, because 4 minus 4 is 0. And x equals 19, because 19 minus 19 equals 0. You take these and you test them out. All right, we're going to plug them in. And make sure the argument on the log is positive. Let's start with x equals 4. All right, if you put a 4 in here, 4 plus 1 is 5, you're okay. Put a 4 in here, 4 minus 3 is 1, you're okay. So the 4 is good. Let's try x equals 19. 19 plus 1 is 20, you're good. 19 minus 3 is 16, you're good. So the log is positive on both of these. So they both pass the test. All right, so that is a bit of a lengthy problem. And that's the whole thing right there. All right, this will be the change of base formula. If you have log base b of x, that equals log base a of x divided by log base a of b. Now, there's a couple things to remember here. The base right here in the numerator and denominator, they can be anything you want, but they must match. Okay? So I'm going to write a little note here that the bases must match in the numerator and the denominator. All right, so when you rewrite it, it can be anything, but the bases must match. And basically, this argument here, I'll do this part in a different color. This argument here, which is x, that is going to be the argument of the log in the numerator. All right, and the base b of the original, that is going to be the argument in the denominator. All right, so the way I remember this, the base is on the bottom. See, the b's match, the base is on the bottom. That's how I remember it. When you rewrite the log as a fraction, the base number is on the bottom. So that's how I remember it. All right, and by the way, this base A, I'll put this in parentheses. It's usually going to be base 10 or base E. Okay, because base 10 is the log on your calculator, and E is the ln button on your calculator. So usually the base is going to be a 10 or an E. All right, this will be example 1. And we're going to evaluate, let me highlight this here. We're going to evaluate log base 7 of 15. All right, and they're saying give your answer to 4 decimal places. All right, so we're going to evaluate log base 7 of 15. Let me rewrite that a little bigger here. Log base 7 of 15. Now, we're going to write it in the form of log divided by log. We said as long as the base numbers match numerator and denominator, it's okay. So I'm going to write this, start it out as log divided by log. Okay, and it's going to be a base 10. Remember, when it's base 10, you don't even have to write the base 10. It's automatically base 10 when it's not written. But I'll write it just for now. All right, and we said the base number goes on the bottom. So this 7 is going to go on the bottom. All right, so the 7 goes right there. And that means the other term, the argument, that's going to go on the top. All right, so that's it. All right, and like I said, when it's base 10, you don't need to write the 10. I just wrote it to show you that it matches, but you don't need to write the 10. All right, so we have log of 15 divided by log of 7. We want to use 4 decimal places. Really, I shouldn't use an equal sign. I should use the squiggly lines because that's what you use when you round off. Let's go to the calculator. Log of 15 divided by log of 7. All right, let's see. Log of 15, close parentheses, divided by log of 7, close parentheses. Okay, so that's what it should look like. All right, log of 15 divided by log of 7. Click equals. All right, we're looking 4 decimal places, so look at the 5th. If it's 5 or more, you round it up. So it's going to be 1.3917. 1.3917. Because there's a 6 here, so it's rounded up. All right, so that's rounded off, 1.3917. And that's it. It's mostly calculator work. All right, the base number goes on the bottom. The argument goes on the top. As long as these bases match, you're okay. We could have used log base E, which is ln. Okay, so that would have worked as well. All right, example 2. Here we have 4 to the power of 2x plus 1 equals 8. All right, and I'll just write off on the side here. You want to solve for x. All right, so how can we do this? Well, remember, if this base number here matches the base of the log, it will cancel. So since this is base 4 and it's being raised to an exponent, I can take the log base 4 on both sides. So I'm going to do log base 4 of 4 to the power of 2x plus 1. And I'm going to do the log base 4 of the number 8. On the left-hand side, log base 4 and 4 cancel, and you are just left with the argument of 2x plus 1. And here I am going to use the change of base formula. Okay, so I am going to just do log over log. I'm going to start with that. And why am I doing that? Because you want the same base in the numerator and denominator. So it's just log over log. And we said the base number goes on the bottom. The base is 4, that goes on the bottom. And the argument goes on the top. That's the numerator. All right. Continuing on, we're solving for x. The opposite of plus 1 is minus 1. All right, so I just did minus 1 on both sides. And here we have 2 times x. The opposite of times 2 is divided by 2. So I'm going to divide this whole thing by 2. That whole thing is divided by 2. Okay, the 2's cancel. And whatever I get here is going to be my solution for x. All right, I suspect I'm going to have to round off again. So let's round off to 4 decimal places. All right, so let's do log 8 divided by log 4 minus 1, and then divided by 2. All right, I'm going to hit equals. I'm going to hit equals here, and then minus 1, hit equals, and then divide by 2, as you will see. All right, log of 8, close parentheses, divided by log of 4, close parentheses. So this whole thing is first, hit equals, and then that whole thing is going to be minus 1. Hit equals again, and then divided by 2. Hit equals again, and it's 0.25. All right, great. We don't even have to round off. All right, forget the squiggly lines. We got it exactly correct. That is 0.25, or 1/4. All right, so really, the funny thing about this one is I could have solved it without logs. I could have made this 2 squared and this 2 to the 3rd, and then just set the exponents equal to each other. But anyhow, that's how you would use change of base. All right, last one, please try it. 8 to the x equals 1/3. I suggest you do log base 8 on both sides and proceed from there. All right, 8 to the power of x, we're going to do log base 8 of 8 to the power of x. And that's going to equal log base 8 of 1/3. On the left-hand side, the bases match. So log base 8 and 8 cancel, and we're just left with the exponent x. On the right-hand side, change of base formula. We're going to do log over log. Okay, where does the base go? Well, the base always goes on the bottom, so the 8 is going to go on the bottom, and the original argument of 1/3, that goes on the top. All right, and going to our calculator, log of 1/3 divided by the log of 8. All right, so the log of 1/3, which is 1 divided by 3, close parentheses, divided by the log of 8, close parentheses. So that's what we're looking at. And rounding to 4, negative 0.5283. Negative 0.5283. All right, so that's it. And like I said, you can use ln or natural log instead of log base 10. It's going to be the same thing.